All right, pre-cal, this week we're going to be focusing on reviewing some important algebra skills that it's imperative that you know how to do these things this week for anything else that we do moving forward when we start our actual work in pre-cal. What I prefer is for you to take your notes in a large spiral or notebook paper. If you don't have notebook paper, there's a wooden table by the window that has plenty of notebook paper in it, or graph paper should you ever need it. But you're going to be taking notes on your own. Most of the notes that we do in pre-cal you will take on your own. Occasionally I'll have handouts or other things that you can just add into your spiral notebook. So today we're going to focus on algebraic expressions and simplifying expressions. Anything that we're going to come across, even multiplying, adding, subtracting. We're not going to do any dividing today, but basically adding, subtracting, and multiplying an algebraic expression. So first thing I want us to remember is combining like terms. So when we are combining like terms, we are adding or subtracting things that are alike. And when I'm looking for like terms, they have to have the same variable and exponent. So for example, an x and an x squared would not be like terms. They have the same variable, but they don't have the exact same exponent. An x and an x squared and x squared, or any other variable that we encounter has to be the exact same variable and exact same exponent. So what I like to do to help myself out when I'm combining like terms is I just mark them through the expression as I'm adding and subtracting them. So some people like to color code with highlighters, markers, colored pencils. I usually just underline them in different ways. So first up on example 1, we have the expression 1 minus 20x plus 90x minus 16. And if any point the video feels like it's going too fast, you're welcome to have the substitute pause it so that you can catch up. Sometimes I don't pay attention to how fast I'm going when there's not other students in the classroom, but I'll try to slow down. So this first expression, what I like to do is start left to right, and I just start identifying things that are alike. So I start with the first term 1, and I look for any other constant in that expression. So I have a negative 16 here at the end. So I'm going to combine 1 minus 16 is negative 15. Okay, then I start working my way through the rest of the expression. This also helps me remember what I've combined and not. Some people like to mark it out as they go. This just helps me remember, oh yes, I've already taken care of those parts of the expression. So then next up, negative 20x is not a constant, it has a variable attached, so I underline it in a different way. So negative 20x is x to the first power, and then the next term in the list is 90x, which would also be x to the first power. So those are like terms. So then negative 20x plus 90x is going to be positive 70x. Okay, these expressions that we're looking at today, we're not solving. There's not an equal sign. We are just simplifying as much as possible. The expression that I have right now, negative 15 plus 70x, 15 is a constant, 70 has the variable x attached to it or being multiplied to it, so these are not like terms. I cannot combine them. So this is as simple as this expression gets. So what I like to do as I'm answering, when I get my final answer, is I box it in or highlight it. This also helps me whenever you take your quiz or test to identify where your answer is. Sometimes people are very nice and neat when they're working things out. Sometimes their work is a little chaotic. So if you can box in your answer, that's going to help me find that a little bit easier. Now, something I talk about with the algebra students as well is it's not just about the answer. I want to see your work when we're simplifying and solving. Now, some of these problems that we're doing today are going to be very basic. Like this one, there really wasn't any work. I just identified the like terms and then added or subtracted them in my head. So I'm going to understand on some of these problems, there's not going to be much work, but for the most part, make sure you're showing your work because that's what we're looking for is the process, especially when we get to more complicated problems. You're not going to jump from problem to answer. You're going to have some intermediate steps in there. So we want to practice that skill along the way. All right, so example 2 says 1 plus 85x plus x minus 69. So again, I just start left to right, And it doesn't matter if you start with your constants or variables. Most of the time, whenever we're writing our answers later on, if there's a bunch of different variables, especially, we go highest exponent to lowest exponent. So in this case, what we would do is start with the 85x, since it's x to the first power, and then 1x. So 85x plus 1x would be 86x. And then my constants, 1 minus 69, is going to be negative 68. So this would be considered writing it in general form, where it's highest exponent to lowest exponent, especially when you have a lot of different variables or variables with different exponents. We go highest to lowest, but technically this is the same as if I started with negative 68 plus 86x. Those are the same answer, just most of the time we put the variables first. All right, so now we're going to look at some examples using the distributive property. So the distributive property is just implying multiplication. So you see in this example 3, I have 9x plus 8, parenthesis, 3x plus 6. So the 8 right in front of the parenthesis implies that we're going to multiply 8 times everything inside that parenthesis. So where a lot of people get tripped up, especially in Algebra 1, is they work left to right and they try to add 9x plus 8 or whatever those terms are in front of the parentheses. They try to do that first and then distribute. We always want to distribute first. If there are parentheses, then we'll combine like terms. So we're going to bring our 9x straight down, and I'm going to distribute the 8 times both terms in parentheses. So most of the way that we indicate we're multiplying is we draw those little rainbows that show, hey, I'm going to multiply 8 times 3x. So plus 24x, and then 8 times 6 plus 48. After we've distributed, we want to see if we can combine like terms, just like we did on the first two examples. So I'm going to identify any like terms in this expression. So starting left to right, or starting with your x's first, I have 9x plus 24x. So that's going to be 33x. And then my 48 is all alone, doesn't have any more constants to add to it, so we'll just put plus 48. So this simplifies to 33x plus 48. All right, so next up is example 4. We're going to throw in some bigger numbers here and some more distributive property. So I have negative 48 parenthesis 12 plus 23x close parenthesis minus 19 parenthesis 7 minus 22x. So we're going to distribute first on both sets of parentheses, and then we'll combine like terms. So I'm going to start on the left side. Negative 48 times 12 is negative 576. Negative 48 times 23x is negative 1104x. I go to the second set of parentheses. Remember, this is a negative 19. It is read minus 19 as well. Minus and negative are technically the same mathematical operation. So we're going to multiply the negative 19 times 7, which is negative 133. Negative 19 times negative 22x will be plus 418x. So we've distributed through both sets of our parentheses. Now we're going to combine like terms. So I'm going to start with my x's. I have negative 1104x and plus 418x. So when I add those together, that's going to be negative 686x. And then I have my constants. Negative 576 minus 133 is negative 709. So hopefully you're probably not going to be able to multiply these larger numbers in your head. If you need a calculator, there are those in the corner that you can borrow during class. Just make sure they're returned. I would encourage you to either rent a calculator from the librarian or purchase one on your own, because you're going to need it heavily in this class. All right, so those previous examples, we were distributing a monomial times a polynomial. There could have been multiple terms in those parentheses. The next couple of examples, we're going to be multiplying binomials. So remember, a binomial is two terms. So two terms in parentheses being multiplied by another set of two terms in parentheses. They are both binomials. So we have two different ways or methods that we use to help us multiply binomials. So one is the FOIL method, which just means first, outside, inside, last. It kind of helps us distribute those terms and remember what to multiply. The other method is the box method. And so I'm going to show you both methods. Some teachers are more familiar with one than the other. Some students prefer one method over the other. It doesn't matter to me which method you use as long as you're showing your work. It's accurate and you get the correct answer, we're fine. So first I'm going to remind you of the FOIL method. So FOIL is just to remind us what order to multiply things. Really, it doesn't matter the order, it just helps us remember. So first means we're multiplying the first two terms in each set of parentheses. So 2x times 5x is going to be 10x squared. So remember, when we multiply variables, we're really adding their exponents. So x to the first degree, x to the first degree, together that would be x squared when we multiply. Okay, then outside O is the outside two terms, so that would be 2x times negative 6. So it's going to be negative 12x. Inside is going to be the inside two terms, which is 5 times 5x. So it would be plus 25x. And then L, the last two terms, is going to be 5 times negative 6. So that's going to be negative 30. Okay, so remember, just like a while ago when we distributed, we're multiplying again, so we want to combine our like terms. So notice this time we have some other types of terms in this. We have an x squared, an x, and a constant. So this is where we usually start with the highest exponent, which would be x squared. So 10x squared would go first. Then I would add my x's. Notice those are the middle two terms. Negative 12x plus 25x is going to be plus 13x. And then our constant doesn't have any friends, so that's just going to be minus 30. Okay, so our answer would be 10x squared plus 13x minus 30. So I'm going to do the same problem using the box method. Sometimes people prefer the box method just because it's an easier way for us to organize the information and to see it. Some people struggle with FOIL. Which things have I multiplied? What do the letters stand for? So it's just a matter of preference. So with the box method, because we're multiplying binomials, we need a 2 by 2 box. So we're going to take one of the binomials and write it on top of the box, and the other we're going to write along the side. What's important here is this one along the side, so notice I put the minus in front of the 6 and not just in between those two terms. So this is just like a multiplication chart or even a Punnett square that you've seen in biology. We're just multiplying things that match up in the box. So when I do 5x times 2x, that's 10x squared. 5x times 5 is 25x. Negative 6 times 2x is negative 12x. And negative 6 times 5 is negative 30. So notice these are all the same components that we had after that first step of foiling before we combine like terms. We're getting the same answer. So what usually happens in the box method is most of the time diagonally is where you're going to see those like terms. So occasionally it's not going to work out that way, but a lot of times that's a good way to check for your like terms. So then I would combine like terms just like I did previously, and that's going to give me the same exact answer that I had before, 10x squared plus 13x minus 30. So again, it doesn't matter to me which method you use. Just make sure you're showing some work, and then I can see your process. All right, example 6. We have two binomials again, 5x plus 3 times 5x minus 3. So you might notice something special about these two binomials. We're going to multiply them out, and we're going to see what we can remember from Algebra 1 or Algebra 2. So I'm going to FOIL on this one. So 5x times 5x is going to be 25x squared. outside is going to be 5x times negative 3, so that's negative 15x. Inside, 3 times 5x is plus 15x. And last, 3 times negative 3 is negative 9. So what's special about these binomials is you notice when I go to combine like terms right now, these middle two terms are going to cancel out. Negative 15x plus 15x, those cancel and they're gone. So I'm left with 25x squared minus 9. So this is a special binomial. This is called a difference of two squares, and sometimes we just abbreviate it DOTS for a difference of two squares. It's called a difference of two squares because there's a minus in the middle and the two terms are both squared terms. So 5x times 5x was 25x squared. 3 times 3 was 9. Those middle two terms canceled out because we had 1 plus and 1 minus. So this is one of those that if you recognize it from the problem, oh, it's the same binomial 1 plus 1 minus, then I have a shortcut. I can skip ahead and just do the first and the last. The inside and the outside are going to cancel out. A lot of people don't remember it and they just FOIL it or box it out. You're still going to get the same answer. It's just this is one of those shortcut problems. If you make that recognition, you can kind of fast forward to the answer. So here's another special situation that we're going to come across is we have a binomial that's being raised to a power. So remember when something is squared, that really means something times itself. And so what people are tempted to do is they try to just distribute that square into the parenthesis. It doesn't work out that way. So something squared means something times itself. So this is really 2x minus 2 being multiplied times 2x minus 2. So anytime you have a binomial or a polynomial raised to a power, you want to rewrite that polynomial and you're going to multiply it out, whether that's with FOIL or box, whichever method you prefer. Okay, so this time I'm going to use the box method. And again, you can use any method anytime. I'm just trying to show both of them so you can see them as we go. Okay, so we draw a box, we put the polynomials on the top and bottom. In this case, they're both binomials. So we're going to multiply what matches up in the box. 2x times 2x is 4x squared. 2x times negative 2 is negative 4x. Negative 2 times 2x is negative 4x. And negative 2 times negative 2 is going to be plus 4. So again, in the box method, most of the time, you're going to have those like terms diagonally that we're going to add. So I'm going to start with the highest exponent, 4x squared. The middle two terms, negative 4x and negative 4x, will add to negative 8x, and then plus 4. So this is another special situation. These are called perfect squares. So when it's the exact same binomial, multiplied times itself, or a binomial squared, that's a perfect square binomial, it's always going to work out in this pattern where you have the first term squared, the last term squared, and the middle is always 2 times those two terms squared. Sometimes people forget the pattern. So again, this is just one of those, if you FOIL it or box it, you're still going to get the same answer, but hopefully you can make that recognition, go, oh, I recognize this is a perfect square. I know how to kind of fast forward to the answer. But if you don't, it's okay. You can still work it out and get the answer the same way. Okay, we've got 2 more examples. This time we're going to be multiplying polynomials. So you notice in example 8, I have a trinomial times a binomial. So 4x squared plus 6x minus 1 is being multiplied by 6x plus 3. So FOIL is not going to work when we're multiplying polynomials because FOIL only has 4 letters in it, and that's when we're multiplying a binomial times a binomial. So for polynomials, I prefer using the box method. Some people just distribute all the different things, but you end up with all these different rainbows going on, and it can get a little messy. So I really like, especially with multiplying polynomials, to use the box method. So since we're doing a trinomial times a binomial, I need a 3 by 2 box. or a 2 by 3 box. It really doesn't matter which direction you go, you're going to get the same thing. So I'm going to take my trinomial and I'm going to write it across the top, 4x squared plus 6x minus 1. And my binomial along the side, 6x plus 3. And we're going to multiply. So 6x times 4x squared, this time this is going to give us 24x to the third. Remember, when we multiply those variables, we're adding those exponents. Okay, 6x times 6x is going to give me 36x squared. 6x times negative 1 is negative 6x. And it doesn't matter the order that you fill in the box. I could have done the first column, second column, third column. I just like to go left to right. So now for that bottom row, 3 times 4x squared is going to give me 12x squared. 3 times 6x is 18x. And 3 times negative 1 is negative 3. So again, we've multiplied. We need to combine like terms now. So we're going to start with our highest exponent, which happens to be x to the third power. So 24x to the third. There aren't any other x to the thirds. Okay, then I have my x squared. So notice 36x squared plus 12x squared. So together that's going to be 48x squared. Okay, next will be my x's. So negative 6x, and notice diagonally I have plus 18x. So that's going to be plus 12x. And then at the very end, negative 3 is our constant all by itself. So our answer is 24x cubed plus 48x squared plus 12x minus 3. Okay, we're going to do one more. This time I'm going to use the distributive method. It wouldn't be considered FOIL because we have a trinomial times a binomial. If you prefer to do the box method, you're welcome to. I'm just going to show you multiple ways that people will work these out. So first up, we would do 8x squared times 2x. So I would draw a rainbow to both of those. So that would be 16x to the third. And then 8x squared times negative 7. Negative 56x squared. So I've distributed the 8x squared to both terms in the second set of parentheses. Now I would go to the next term in that first set of parentheses. So sometimes this is where colors are helpful. So if I do 2x times 2x, that's going to give me plus 4x. 2x times negative 7, negative 14x. And then I would switch colors. And this is where it gets messy, and I don't always like to do these rainbows. So negative 6 needs to get distributed to both of those. So negative 6 times 2x is negative 12x. And then negative 6 times negative 7 is going to be plus 42. Okay, so now we're going to work through and combine all of our like terms. So starting with our highest exponent, that's going to be 16x to the third. Then my x squared, I have a negative 56x squareds, no other x squareds. Or did I miss one? Let me double check. I did. I didn't write 4x squared right there. So negative 56 plus 4 will be negative 52x squared. So these are kind of lining up nicely. So notice I did a single line, double line, now I'm going to start doing a wiggle. So negative 14x, negative 12x is going to be negative 26x. And then I'll do a double wiggle for 42 at the end. So our solution is 16x to the third minus 52x squared minus 26x plus 42. All right, so that is our review on simplifying expressions. So now you have an assignment that you're going to work on. You have the rest of class to work on it today. If you don't get it finished today, then you need to turn it in tomorrow for your assignment, for your homework.